Welcome to the lecture on project balance. So, in this lecture we are going to discuss, we have already discussed about the alternatives comparison methods, and to introduce this project balance, what it is one of the method of measuring economic worth of alternatives. So, when we are talking about different alternatives, then it is said to be one of the method by which you can measure the economic worth. Now, what it does typically, that we must know. So, it describes the equivalent loss or profit of a cash flow as a function of time. So, basically what we know, that in a typical financial transaction cases, you will have the receipts and disbursements at different times. So, in a typical investment for a typical investment company, something will be invested at 0 time, and then certainly, so that will be a disbursement, and then in future you are going to have the receipts. So, you are going to get the whatever you have invested, so that will give you certain fruits, like you will be getting some income, profit and all that. So, there will be receipts in due course of time. So, now what happens that now if you are to ascertain that at any particular instant where you are, what is the status of the company, so that basically will be measured by finding this project balance, and there will be project balance diagrams also that will tell us about it. So, it describes the equivalent loss or profit of a cash flow as a function of time. So, what it will do is the net equivalent amount of money tied up or committed to the project at each point of time over the life of the cash flow. So, it will talk about the equivalent amount of money which is tied up or committed to the project at each point of time. So, what happens that many a times there may be the company may be terminated, the project may be terminated at unexpected time. So, you will be able to know that what is the status of equivalent profit or net equivalent. You are in the state of profit or you are in the state of loss. So, that basically will be computed, that will be known to you by using this finding the project balance at that particular time. For example, suppose that you take one cash flow, and this cash flow typically you have invested at 0 times. This is 0 time, and then you have 1, 2, 3, 4 and 5. So, you will have 1, 2, 3, 4 and 5. So, now suppose you have invested 1000 rupees. Now, here 10,000 rupees initially. So, that will be basically in the negative with negative sign, and then you have the cash flow, that is in the first year, and you are getting 1000. Second year you are getting 5000, then further third year you are getting 8000, and then fourth year you are getting 6000, and then further you are getting 3000. Now, suppose you see that this is the cash flow for a particular investment. Now, you need to know that at particular time what is the status, whether if suppose the project is terminated at any stage, then at what stage it is, whether you are at loss or whether you are at gain, or you are at a position of no loss or no gain. So, like that will be ascertained by calculating this project balance in that case. Now suppose for this case, suppose interest rate is taken as 20% per annum, so compounded annually. Now what we do is that when you are taking this project, so before so at present, if you take the project balance at present, if you assume that now the project is terminated, you have the company has already put in 10,000 of rupees or a person has put in 10,000 of rupees and the project is terminated. In that case, what is the project balance? So project balance at rate of 20% interest rate at time 0. So this is time 0, and if you look at that, that will be basically 10,000. So it will be minus of 10,000. That is what the meaning of this project balance is. Now suppose you have invested, and now you are coming to this time 1. Now at time 1, what will be the project balance? Now if the rate of interest is 20%, in that case at this time the value of this 10,000 will certainly not be 10,000, because there is interest rate attached to it. So if you find the project balance at 20% for time equal to 1 year, in that case what will happen, that this 10,000 it will have the value. So it will have the value at this point, you will have to multiply with f by p I n. So it will be minus of 10,000 into 1.20. So that will be the factor, as you know. So that will be f by p I 1, and then at this point you are getting a receipt of 1,000. So if you give the receipt of 1,000 in that case, so you are getting minus of 11,000. So what we see, that you were having the deficit value, net net present value, net present present balance value as 10,000 at 0 time, but after an year, although there was a receipt of 1,000, but the project balance, if you calculate, this project balance will be further decreased. So it will be going to minus 11,000. So instead of 10,000 it has gone to minus 11,000, and it is all because of the value of this 10,000, which has become 12,000 after a year. Then you go to the project balance for 20% at time equal to 2. Now at this point, at time equal to 1, your value was minus 11,000, and then you are further calculating that project balance at a time 1 year ahead. So that will be at this point you had 11,000, at this point you had 11,000 minus of 11,000, then its value will be further, that is to be multiplied with 1.20, and then you had the receipt of 5,000 at n equal to 2. So 11,000 multiplied by 1.2, so it will be 13,200. So it will be minus of 13,200 and plus 5,000. So you will get it minus 8,200. So what you see, that the project balance has now decreased because of the receipt which is there at the end of second year equal to 5,000 rupees. So this way project balance has changed. Now you can then further you can calculate project balance at n equal to 3. So it will be again minus 8,200 multiplied by 1.20, and then at n equal to 3 you have 8,000 rupees. So 8200 multiplied by 1.2, so it will be 9840, and so it will be minus 9840 plus 8000. So it is still coming out to be minus of 1840. Then you can similar way you can calculate PB 4 and PB 5. So if you calculate this PB 4, so PB 20 at 4 time, it will be again you have minus of 1840, and that will be multiplied by 1.20, and at n equal to 4 you have the receipt of 6000. So 1840 multiplied by 1.2, so it will be 2208. So it will be minus of 2208 and plus 6000. So it will be 3792. So it has gone to, now it has changed its sign. Now what you see that if you continue the project up to 3rd year and discontinue, then what you see that you are still at the net present project balance value, that is minus of 1840. But if you go to 4th year, in that case the project balance value is changing its sign from negative to positive, and now it has come to 3792. So basically that much time it must run so that it gives you profit, otherwise you are going to have the loss. So this is the time which is very important. Further you can also calculate PB for 5, and then that will be 3792, then again multiplied by 1.20 plus then you are getting 3000 further. So 3792 multiplied by 1.20, so it should be something like 4550, something like that, and then plus 3000. So it will be 7550. So you see that at the end of the period n equal to 5, what you see that your project balance value is coming out to be 7550, and up to PB 3 you did not cross that demarcation line from negative to positive, but once you have gone to the 4th year, taking into account the transaction of 4th year, you are coming to a positive sign indicating the profit, and then that profit has further increased as you go to the 5th year. So this way you can have a generalized type of expression even for that, and you can write that for PBI and PBI for any time t, it will be what you have done is you have got the project balance at PBI of at t minus 1, and then you have added this transaction which is there at time t. So this way for t equal to 1 to n, you can find these project balance values, and what you do is that you use these positive and negative values and then interpret that how that is going to be useful for coming to a decision that how long the project should run, so that you are at a stage of profit or a loss. So what happens that you can draw the project balance diagram basically for presenting it, and what you see is that you calculate this project balance values, and what you see, what you have seen in this case, this is project balance with 20% interest rate. So this is your 0, and one side you have profit, one side you have loss, And what you see is that you have this is this is 1, 2, 3, 4 and 5. So, as you see that for 1 you get minus 10,000. So, this is how this line will move. So, this will be your PB 20 at 0 will be minus of 10,000. Then once you come to 1, then after that you further dip to 11,000. So, PB 20 at 1 will be minus 11,000. Then at 2, once you have come you have come to 11,000. Then at 2 once you come, you are coming to minus of 8,200. So, here you are coming to minus of 8,200. Then you are further moving to minus 1840. So, it will be at this point you will be writing PB 22 will be minus 8200. Then you will be having a PB 23. So, it will be minus of 1840, and at 4 you simply move up and you are coming to PB 24. So, that is equal to 3792, and then further at once you reach at 5. So, you go here and this is PB 25. So, that will be your 7550. So, that is how you are going to get the diagram, and this diagram is known as the project balance diagram, and this is useful for for finding that when this project should be terminated. And in this case what you see that when n equal to n prime, that is when taken as equal to 4, this project can be if it is terminated, you will not be in a loss mode. So, that is how this status of the project can be ascertained in such cases. You can also find this project balance. So, if you are using another formula, so you can also find for t time. So, PB for any particular interest rate at any time t, that you can find by summing this t equal to 0 to t, and then whatever transactions you have at whatever time t will start from 0, and then 1 plus I raised to the power t minus t. So, that way for t equal to 0, 1, 2 to n. So, for this you can use these transactions and you can find the project balance value. So, if you are taking all these transactions in one go and try to find the project balance, so that way you can use this formula and also find it. Now, we will also discuss about the other traits of this project balance, and as we discussed that project balance basically this diagram depicts 4 important characteristics. Net future worth of investment. So, basically when you are finding the value at the end. So, when you are finding the project balance diagram, then in that case the value which is there in the end, that will be shown as the net future worth of the investment. Then we will see that apart from that, you also know that when the equivalent amount will be switching from negative to positive. That is what we have seen, that when this equivalent amount which we are calculating, that is whether when that will be switching from the negative value to the positive value. So, in that case you are getting this at t equal to 4. Then you also know net equivalent committed money exposed to risk or loss, basically this is risk or loss, and also in the end you have the net equivalent money earned. So, that also you can find. So, what you can see that if you draw this any particular project balance diagram. So, what you see that you have this F naught, and then a typical project balance diagram will go like this, and then it will move. So, like this, and then it will move like that. So, now what you see that in a particular, so you have 0 and this is t. So, this way your t is there, and this is PBI at interest rate I, and this is t. So, when we talk about this net future worth, so basically what you find in the end, this one. So, this is basically the net future worth. So, this will be PBIN. So, basically that can be, so this is one of the element of the project balance. Then your time, that is your time when the equivalent committed money switch from negative to positive, and in this case this is the time, and in the earlier case as you have seen that this was basically the time when your equivalent money from it turned from negative to the positive. So, so that is how this time is known as n prime, and this is known as the discounted payback period. So, that is how this period is calculated when there is no profit, or this is changing its sign. So, that basically is known as the discounted payback period. Now, these are the reasons which is exposed to risk or loss. So, this reason, or this reason. So, these are the reasons where you have exposure to risk or loss is there. So, you are likely to be under loss if your project is terminated at this stage. In that case you are under the position of risk, whereas if you are in these situations, then in this case you have the chance of profit. So, it is profit potential. So, this way this project balance diagram is going to be understood, and as we know that you have you must know these when you are at the risk or loss. So, this area which is talking about where the PBI is negative, that is the exposure to risk or loss, and when you have profit potential, then you have the chance of in that case this balance value will be positive, and you are going to have the values positive in such cases. Now, as you know that you may have different cash flow diagrams, and then you are supposed to basically find many a times this n prime, the discounted payback period, and that is basically typically what you are expected to know. And if in the case of different cash flow diagrams, you will have the different cash flows, and in that case you will be calculating the project balance at different times, and then you are going to calculate that what will be the time at which this project balance value that is basically changing the direction. So, for example, you may have different types of situations, like you may have one type of cash flow where you can see that you have minus of 1000, and then you have different amounts coming here, like you have 912684, then 456 and 228. Similarly, you may have another cash flow where you are getting this minus of 1000, and then you can have the cash flows at the 4 times, like 631 each. So, that will be another cash flow. The third type of cash flow may be there, and the third type of cash flow may be like you have minus of 1000, and then you have 284 in the first, then 568 in the second, then you have 852 in the third, and in the fourth you have 1136. So, that may be another type of cash flow, and you may have another cash flow where you have minus 1000, and at the end of 1 2 3 4 you have a receipt of 3641. Now, what we need to know using these type of cash flow diagrams, that what will be your n prime which is required to be calculated. So, for example, if you look at the first case, if you look at the first case, now you see that if for a particular interest rate, say suppose I equal to 25% is given. Now, what will be the project balance values at this time? So, we know that at the time 0, the project balance value will be minus of 1000. Now, if you go to the second value at n equal to 1 or t equal to 1, now what will happen to this? Now, at so suppose this is cash flow 1, and this was cash flow 2, and this was cash flow 3, and this was cash flow 4. Now, if you look at and try to compare these values. So, suppose you are talking about cash flow 1. So, in the cash flow 1, what you see is that at t equal to 0, your project balance value, because you are talking about 0 time. So, the investment is minus of 1000. So, project balance for 25% at 0 time will be minus of 1000. Then if you go for t equal to 1, so now what you see is that for t equal to 1, what will happen? PB 25 1, it will be minus of 1000, and then it will be multiplied with 1 plus I. So, it will be 1.25, and then you have a receipt of 912. So, it will be 1250 plus, so it will be minus and then plus 912. So, it will be minus of 338. So, similarly, if you go to at t equal to 2, in that case PB 25 2 will be minus of 338 into 1.25, and then you have the receipt of 684. So, it will be something like 422 minus of 422 and plus of 684. So, it will be minus of 422 plus 684. So, it will be 262, something like that. So, basically this way you can calculate these values, and you can come to this at t equal to 3, you can calculate, t equal to 4 you can calculate, and then you can see that how these. So, you have seen that in this case at n equal to 2. So, n prime what you see is that you are getting at second time period. Now, this time period basically will be changing for the different types of transactions, and that we can see. So, in the next lecture we can see when we try to solve the problems based on this, then we will see that for different cash flows how can we find these values, and we can get more we can have more clarity about the questions. Thank you very much.